Greetings and welcome to Boiler Room Detective. Just wanted to give a shout out to the great people at heatinghelp.com. It's my go-to site to get information and advice on any HVAC system. I was consulting on a 100-year-old heating system and found everything I needed there. Give it a click and you'll see why it's an awesome site. Okay, to our case. The boiler runs a bit, shuts off, and restarts a few minutes later. It's having a difficult time maintaining steam pressure in the building. While watching the boiler, you notice the gauge class level drops out of sight low, shutting off the burner. You hear the boiler feed pump operating. A few minutes later, water reappears in the gauge class and the burner starts. What is going on? Welcome to Boiler Room Detective Channel. I'm your host, Ray Wohlfarth. Your first thought may be that the tank is too small. This theory assumes the tank never worked since it was installed. It's possible, but not very likely. This video will cover common mistakes I see in boiler feed system installations and later discuss sizing boiler feed systems. Let's get right to it. Number 1, steam trap on the condensate return pipe feeding the tank. Never ever do this. It's called double trapping and will lead to higher fuel costs, reduced feed water pumping capacity, more flash steam, water hammer, and damaged feed water pumps. A strainer on the condensate return pipe is a great idea and seldom done. It captures rust and mud and solids, preventing them from entering the tank and ruining the feed water pumps. Always use the full pipe diameter on the air vent. This is critical for the proper operation of the steam system. Number 4, if you see steam coming from the air vent, investigate the source. It may be leaking traps or high-pressure steam. High condensate temperature could reduce the feed water pump capacity and damage the pump. Water can actually flash the steam inside the pump pollute and destroy the pump. The city water pipe heating the makeup water to the boiler feed system should have a pressure-reducing valve to maintain pressures below 25 to 30 psi. Pressures above that could overcome the float valve and flood the boiler feed tank. Number 6, a strainer should be installed on the makeup water pipe to prevent dirt from entering the float valve. Number 7, I like using a pressure gauge on the pipe feeding the boiler to determine whether the pump is working and the pressure is correct. Number 8, a throttling valve should be installed in the feed water pump discharge. This adjusts the pressure feeding the boiler. If the pressure is too high, it could shoot water up the equalizing pipe, causing water hammer. Number 10, a boiler feed tank must have an air cushion inside. This allows the system to breathe and vent the air from the system. If the tank floods, the system could form vacuums and you will have no heat calls all through the building. Getting back to the boiler cycling on low water, if the tank were undersized, the tank would run out of water and the feed water pump would run without water. You would see the water level in the tank drop and hear a difference in the pump sound. Neither happened. To be sure, you can run a quick calculation of the tank size. To do so, you'll probably get online and use a calculator. For this part, I'm going to show you the old-fashioned way. To calculate boiler horsepower, you divide the boiler output in BTUs by 33,472. Let's say the boiler has an input of 2 million BTUs and an output is 80% of that, or 1.6 million BTUs. A boiler horsepower is 1.6 million divided by 33,472, and we get a 47.8 or 48 horsepower boiler. Another formula you might use is 1 boiler horsepower generates 34.5 pounds of steam per hour. So this 48 horsepower boiler will generate 1,656 pounds per hour. Now let's size the tank. Boiler horsepower times 34.5 divided by 8.337. That's the weight of 1 gallon of water, divided by 60 minutes in an hour times 10. This number could be 10, 20, or 30. This is the time it takes for when the steam leaves the boiler and returns as condensate. It's anywhere between 10 and 30 minutes. So let's size the tank based on these numbers. Here's the formula for sizing the tank. 48 horsepower times 34.5 divided by 8.337 divided by 60 times 10 is 33.11 gallons. You want to add a 50% safety margin. The tank will be roughly 49.66 gallons or round it up to 50 gallons. If the storage tank is 50 gallons or larger, it's sized correctly. Now let's size the pump or the proper GPM. To size the feedwater pump, you need to calculate the boiler evaporation rate. To calculate the evaporation rate, that formula is boiler horsepower times 34.5 divided by 8.337 divided by 60. And that gives us the evaporation rate in minutes. When we plug our numbers in, it comes up to 48 horsepower times 34.5 divided by 8.337 divided by 60. And that's 3.3 GPM. We also use a 50% safety factor on there, so that takes us up to about 5 GPM. The last thing we want to check is the discharge pressure for the feedwater pump. According to code, it should be 3% higher than the safety relief valve setting on the boiler. If this boiler is a low pressure boiler, the pop safety valve would be set at 15 psi. We would need to have 15.45 psi going into the boiler. To see how much pressure we need at the feedwater pump, you would have to account for the piping pressure drop, which includes pipe fittings and the valve. In this case, someone had turned the feedwater discharge valve almost closed. When I opened the valve, the boiler stopped tripping on low water. Please like and subscribe to the channel if you found this video helpful. My boiler books are available at Pronto Heating Supplies in New York and on Amazon. My articles are also included in many industry publications. Thanks for watching, and I'll see you on the next case.